So today we are going to see the design and analysis of a transformer, beam and columns, right? So we can see transformers, the electrical transformers will be placed on the concrete structure, right? So we will design that. So for that, go to new project, click on space, give it as transformer or whichever name you like, right? So click on finish. So we have opened our software, right? So now we will add a point, right? So we will edit our grid to exit plane on OK. So I'm going to select a node point, click on escape. So clear the mesh. Now select this node with the node cursor and copy and paste y direction of. So we will see our units are in meters and kilonewtons, right? So click on OK. So click on paste, about y direction. So we are going to take as, so its actual height will be of almost around 3.5 meters, right? So if we go to meters or feet, so if we take the 6 feet, means it will come as like 1 point. So we will take it as 2 meters, right? Or we will take 2.5 meters on OK. So now here we got this, right? So now we need the four sides, right? So select this node point, copy and paste. So toward z direction of how much? 0.5 meters. So and again paste and minus z direction of 0.5 on OK. So and again paste x direction of 0.5 and again paste. So I'm doing directly paste because the node is already selected, right? So minus 0.5. So now we need to connect this, right? So go to add beam, select this point, now add this. So now we need to add some node points over here because we need a slab, right? So for that, again I am going to my node point. So we can see our distance, right? So this is 0.5, right? So now again go to node cursor, select this node, copy and paste toward minus 0.5 on OK. So and again paste and select this as plus 0.5. So here it has created, right? Now you will for this node point copy, Control C and Control V. So it is also about minus 0.5 and again paste 0.5, right? So we have all gathered. So now we will add this, right? So add beams like this, or else we directly add the plate, right? So take the 4 node plate, 1, 2, 3, 4, right? So if we go to 3D, so here we can see our plate, right? So now we will assign the support. So go to general, click on support, create, select the fixed support, select over here, assign to selected beam nodes, on S. Here it and assign. So now we will go to property, go to define. So we will wait until our opens, right? So go to rectangle. I'm going to take the column as 0.45 by 0.45. Can add, close, and go to define. We want 0.35 by 0.35. Add and close. So I'm going to select this. Beams parallel to y direction. Assign and S. So it has assigned. So here we can see our column has assigned, right? So now again for this to missing that one, missing property. So this is all missing property, right? So we'll go to beams parallel to X, beams parallel to Z, right? Call assign and S. So after that, go to thickness. So we are going to create 0.3. Call add and close. Assign to view, assign and close. So now here we can see so here we have done our beam and slab section, right? So now we will go to our loadings. So we'll define the wind loads also for this. So for that we to go add dead load, and we will add the wind load, WX, and WZ, right? And close. So we'll do first of all we have to define the wind. Go to add, close. Select this one, add one. So calculate as per C. Then we take as some structures. So second, category 4. OK. And add, drag drop one, add and close. Select this one, is going to view, assign and close. So it has assigned, right? Now go to dead load, click on add. Now add the self weight, and we will add the member load. So for the member loads, we want to calculate, right? So go to calculator, 0.45 into 0.45 into 25. This is how much? 5.062. Y direction, add. Now again go to 0.35 to 0.35 into 3 point. So here I forgot to put minus. So we'll add the I also, add it. So now we have the slab 0.3 into 25. 7.5, right? Minus 7.5. So now we will go to plate loads. Pressure on full plate, right? So we are going to take it as minus 100 kilonewton per GY direction. Call add and close. So we will delete this plus ones. So we will do this double, right? So here we go, right? So now we go to wind, add, go to wind load, export, no miss, one, also miss, 3, 1, notice, 2.58, and add and -1 and close. So you can see the dimensions, right? So here you can see it is 2.5, right? So now add the Z words, wind load, Z variation 1 and this is 2.5, add -1, add and close. Now we will assign this, assign to view, assign this. So we got this for our column, right? We need to select this column to the direction. Assign to selected view, assign and close. So and again this for our beams, X, Z. Assign to selected beams, assign beams, right? Now this is on our plate loads, right? So go to plate load, select the plate, assign to selected beams, this, and this is also for the plate only, right? So this is our beam, but we cannot see because it won't be applied, right? At the height of this one, right? So now we will add materials, concrete, assign to view, assign this, right? So we will see there is only missing attributes of the line. Don't require wind because it is a height of just 2.5, right? So it won't be applied any wind loads, right? It is very low loads, right? So now we'll go to our analysis and print, right? Anything is missing, go to select missing attribute, missing plot. So there is no missing property, right? If you see here, so this is our structure. So now we'll go to analysis and print, add, close. So now we will go to we have done this add, close. Now go to analysis, run analysis. So here we're done with 0 errors, 9 warnings. Warnings can be neglected. So click on done, on OK. See the animation, you can see any deflection is. So here we can see, right? So now we will go to our design part. So go to design, select the concrete, IS456, select parameters, deselect this, compressive strength and yield strength. So right, we are going to take that. On OK, define parameters. So we are going to take the 25 and equals 415. On add, close, commands, go to beam, add, column, add, slab or element, add, take off, add and close. Now we have to assign this, assign to view, assign and close, assign to view, assign and close, design beam, select X, element to Z, assign and close, design column, select element to Y, assign and close, design element, assign to view, assign and close. It has a sense. So now go to analysis and print, add, close, analysis, run analysis, save. So we are done with our 0 errors. To post processing. So here we can see the beams, reactions, right? So this is the beam concrete design. This is the deflection shear bending of the beams. So we see for this column, This is the concrete design, right? So here you can see. So there is shear energy force, the loading properties, everything. We can see the animations. Okay. So different thing like this. If you go to plate shear stress contour, maximum absolute stress. Okay. So we can see the shear distribution, right? So this is how we can, and we can see the concrete design by go to reports. So here we go to results, concrete design. So here we'll get the all the summary of shear reinforcement and the beam dimensions and the shear, the bottom shear like how much. So everything will be we can get in our reports. We can print by going to print. Okay, so if we click on OK, it will ask for the location to save. We can save that. So this is how we can design a transformer column beams and slab, right? So you can change the size. I have given the big size. You can change it to however you want, right? So thank you.